In this video, we're going to talk about entity model class initialization. This is a very, very important part of Flame's entity models. I have my Visual Studio solution opened, and I have the F-tutorial project loaded like we're doing for all these entity model tutorials, and I'm looking again at the EXM sensor class, which is the class that we are using for the entity model developer training tutorials. So initialization is performed by a method simply called class initialize. So before we look at the details of this, let's take a look at how this method gets called, and we'll talk about when it gets called. This is a C++ method. And we have to have a way to be able to call this from code written in C. And of course, member functions of C++ classes can't be called directly from code written in C. So what we have always at the bottom of the base file is an external C function that's called the same name, but it just doesn't have the colons in it. It's always the name of the class followed by class initialize, and it simply calls the C++ member function. So if we go and look at the definition of this class, since we don't have an instance of the class available yet, we can't invoke a normal member function. It has to be a static member function. Static member functions are functions that are defined for the class overall, and they are not invoked for a specific member of instance of the class, a specific class object. It's because, as it's pretty clear in the case of create, or in the case of, I'm sorry, I'm looking at the wrong thing here. It's class initialize. It's also static. There is no instance of the class available at the time that this is called. The same is true for create. So class initialize, and then we're going to talk about class initialize UI in just a minute. Class initialize is a static function again because there is no instance. So we'll go down here. So this allows us to call it without an instance of the object. So that calls this particular routine right here. So when does that class initialize function get called? Well, it gets called in the overall and initialize components function for the entire DLL. The entire DLL that's going to get created when this Visual Studio project gets built. So we have in each DLL, there needs to be one function, and we put it in a file called initialize components. It doesn't really matter the name of the file, but that's our convention usually. So we have a file in here called fire, flash, and forge. They're arranged alphabetically. And these files, these functions are the functions that get called by the respective applications when the applications initialize. So let's go look at Forge and the Forge status window. We've talked about this before. When Forge starts up, it loads different DLLs, the DLLs that are specified in the environment when Forge runs. So we've loaded our ftutorial.dll. And after the DLLs are loaded, Forge will look at that DLL, and it will look for a function that is specifically named Forge initialize components. So the DLL has to have this function in it in order for it to get initialized properly in Forge. That's the only function that Forge looks for specifically in that DLL. It doesn't need to know any other functions. So it calls this function. So you have to write this function, or if you are using one of the component library, component DLL, plugin DLLs that are pulled out of the Flames repository, this function will already be there. And what this does is it calls the class initialize functions for all of the classes that are in your DLL. So that's how that class initialize function gets called. You'll notice here that it's calling the UI version of it. We're going to talk about that in just a second. Classes that can be edited in Forge that have user interface will have two class initialize functions. One of them is a UI function, and one of them is the what we call the non-UI function. So if I go over back to my H file, you'll see that there are two of them right here. We'll talk about each of those in just a second. But in Forge, when it calls this function, since Forge is a graphical user interface application, we have to initialize the class and prepare it for use in a graphical application. So we will call the user interface version of the initialization. So there is our, let's see, I think it's down here. I put it at the bottom. So here's our sensor class getting called right here. So that's how this function gets called right here, and then that function then calls this. Now, inside of this initialize components file, there's also a version of the initialized components for Flash. So when Flash loads a DLL, it calls this function, and you can see that there are many fewer calls inside of this function because most classes are not actually ever instantiated in Flash. Flash is just a viewer, so it doesn't have to instantiate it. And then there's Fire, and Fire usually initializes all the same classes that Forge initializes, but you'll see that this is the non-UI version. There's no UI, and that's because Fire does not have a graphical user interface, so we initialize the classes differently. So that's what happens when an application loads the DLL. It calls this initialized components, that ends up calling it. So when we do the tutorial to show you how to create a brand new entity model class, one of the things that we'll have to do is we'll have to create our class initialize function, then we'll have to edit these functions right here to make sure that our new class gets called during class initialization. This macro right here is it's pretty simple. You don't have to use that if you don't want to in your code, but what it does, you can see here in this definition, is that it creates the prototype or declares the prototype for the function. Then it calls it, and if it fails, it announces an error message that says that it failed. So it handles the error reporting. It doesn't cause this function to return failure. So if your class fails to initialize, it'll still keep going. It'll still try to initialize all the other classes, and it'll still continue on loading all the other DLLs and initializing all those classes. It doesn't shut down the entire initialization of the application. But as you'll see in class initialize, if you are returning failure, it's likely that the class was not registered properly, not initialized properly, which means that no instances of that class will be able to be created. So if you load a data set that has data in it for a particular class that later does not initialize, that data, when you try to load it, will get ignored, and you'll get an error message from Forge that says, hey, I've got data in this file for a class that isn't initialized, and it'll tell you that. But most of the time, if you write your classes, all these classes, of course, initialize properly, and you get yours built, it'll initialize properly, and you won't have any problems. So I can close this file off. And now let's go actually and take a look at the class initialize function. So we're going to look at the non-UI class initialize first. For all the entity models in Flame's components, their class initialize function looks very similar to this, as is the case for most things about entity models. There's a lot of things that are similar. So what you're learning here will apply to all Flame's entity models. There's this macro that we put at the top of all the class initialize functions, and that macro actually gets defined by this little macro reference at the top. So this guy actually just expands to define a couple of variables. So it's not including anything. It just defines a variable, a static variable called class initialize started and class initialize finished. So with this macro at the top, we can now, and what this does is it just says, it checks to see if class initialize has started. And if it's started or finished, it just returns success. So what that prevents from happening is multiple calls to this function. So if somehow, some way, there's a recursive mistake in the code, and this class initialize function is getting called in a nested situation, it'll prevent that from creating an infinite loop. And it also checks to see if class initialization is already finished. So if it has been finished, it will return success. And that prevents this function from getting executed twice. So even if it happens to, by mistake, get called more than once, the second time it will return success without doing anything. And that's because in this end initialization macro, which we have at the bottom, we set class initialization finished to true. So that's what that macro does. The first real code in class initialize function is always to call the class initialize function for the parent class. So that makes sure that the class is all set up the way it needs to be. So it's your job to know which class you are inheriting. So you can go back to here. We're inheriting the FCPP class right here. So we make sure that we initialize that. And that'll be one of the things that would cause class initialization to fail. If somehow that fails, we would return fail and our class would not be initialized. Then we do our own initial. Well, actually, no, what this is doing, this is a method that is defined in the parent class. So the parent class has a default object, and we will make sure that our instance of the default object within our class is being initialized properly. So let's talk about that default object for just a second. This is our default object that we're referring to right here. This is it right here. So let's just talk about that object for just a second. This is a static object, which means there's only one of them. This is a standard C++ declaration. There's only one of these guys. So even though it's declared, it looks like a member function, there's only one of them. And you must define the instance of that at the top of the file. So here's where we define it. And this is the proper syntax for declaring static or defining static objects. So that object always exists. So in our class, we have this object. And there's one of these guys in this class also. And all the way up the chain, there's default objects in all of the classes all the way up the line. So we have to make sure that the default object for our parent class is initialized properly. And all the defaults that are in the inherited members of our class are set. Now, this call right here to class initialize has the same macros in it. So if there are multiple C++ inherited classes or classes that inherit the CBP sensor, this second call will only do it once. So we only have to make sure that, and the same thing is happening right here. If this is happening, it'll only get initialized once. But it is important that we initialize the default structures of all the inherited classes that we're inheriting. So that's what that line does. So then the rest of this function is going to be working with our default structure. Now, one of the things that's extremely important for a multi-threaded execution and for checkpoint restart, particularly checkpoint restart, this default object can be changed. You can set values in it during class initialization. But because this guy is a static variable and it's not being allocated dynamically by the Flames memory allocators, the values of this structure will not get saved to a checkpoint restart file. So if sometime during the execution of this scenario, you changed one of the values in that default structure, create a checkpoint, then restarted with that checkpoint file, your default structure would not remember the change that you made. So it's an absolute concrete rule in Flames that you only set the values of the default structure during class initialization. So we're doing that a lot right in here. But then after that has been done, we don't ever touch the values of the default structure. And because a class is going to get initialized the same way every time we start an application, whether we start it for the first time or whether we're starting it for a restart operation, this class is always going to get initialized exactly the same way. So we don't have to save its value. So again, what we're doing down through the rest of this method here, this class initialize member function, is we're setting up our default structure. So first thing we do is we set the name. We add an interface tag, and we'll talk about interface tags later. So if your class supports certain interfaces, you have to specify the names of those interfaces here. And then we do this, so after the name has been set and after we've initialized the inherited members of our class, we then pass our class to Flames. And we tell it what's the primary class, and in this case it's always the C variant of the primary class, what's our specific class name, and we give it the address of our default structure. So this is arguably one of the most important function calls in all of Flames. This is what tells Flames about our class. And because Flames knows it's a component class, and because we've identified the primary class that actually knows it's a sensor class, it expects certain things to be there. And of course, because we've inherited fEntity and fSensor and component, those things are going to be there if you've implemented it correctly. So that's all that Flames needs to know to be able to do all the magical things that it does for you automatically for your class, because it's a member of the fEntity class. So then there's a few more initialization things that we do. We have to set the create method, and there's no way for Flames to know the pointer to that or to invoke the create method, because as we've talked about already, the create method is a static function. So we don't have an object that we can use to invoke this method. So we have to let Flames know the pointer to that. So that's what this guy does. And we store that pointer in our default structure. Flames knows where to get it when it needs to create an instance of that class. And then it's a good idea to set default values for all of the values in your class. And those will be the values that show up in Forge when the class is empty, when it comes up for the first time. But of course, you're going to override those values and put real values in it when the user is going to do that. But if we happen to define new values that are not saved in an earlier version of the data set, we need to have default values, and we'll talk about that in the tutorial where we teach how to add new attribute values. And then we define the database input-output record, and we talk about that when we talk about the input-output operations for a class. And that's pretty much it. It's very simple when you write your own classes, and you'll be copying this code, and all this stuff will all be done. All you'll have to do is just change this bottom part right here to adjust it to the specific attributes, the specific member variables of your class. But this top part right here is pretty much the same, with the exception possibly of the interface that you're specifying. You'll see this part at the top of pretty much every single entity model class, and you won't have to edit it. The model copier will rename everything in here. You won't ever have to touch the code here. So before we finish the class initialization, I want to go and take a little bit closer look at the definition of the class. So we've already talked about, this is just standard C++ syntax for inheritance. So we're inheriting the C++ sensor class. We declare our static variable. We've talked about that. This is the place where the class gets to define the input values that are going to be able to be set through the user interface. And we'll talk about those in another tutorial. This is where we declare all of the member functions that are inherited from parent classes. Some of these come from entity. There will sometimes be some that will come from the specific class that we're inheriting, like detect, for example. That only comes from sensor models. Control only comes from equipment models. But alter, clone, configure, those are all methods that are set up for all entity classes, and then all of these down here are also set orientation is specific to equipment models, right? You'll see these or some of these in other classes. A lot of times you won't see the IO and the UI methods, and we'll talk about that later. So I'll go over here to the EXM radar. You'll see there are many fewer methods right here for this particular class, because it uses the default implementation of some of the methods. We'll talk about that more later. So we have here the create method, which we've already talked about. So now here's the constructor and destructor. We talked about that in the life of an entity model. And then we have the class initialize functions that can be called from C. So the last thing I need to talk about here about class initialization is this function right here. So that function is declared at the bottom of the UI file. That's our convention. So this is a C callable function, and just like the class initialize, it calls the member function right here. And here is the class initialize UI function. So the first thing that it does is it calls the non-UI class initialize. So all the things that happen during class initialize also happen in class initialize UI. And remember, just in case, if you want to remember, where we call the non-UI one from Fire, we call the UI one from Forge. So we do everything that's necessary there for non-UI, and then we do just a couple of additional things. We call this function right here. This is a function that is resident and was generated automatically when this template file was compiled. So if I went inside that file, one of the things I would find would be this function. So this takes all the code that was automatically generated when the user interface template file was compiled, and we'll talk more about this in another video, that when this file gets compiled, it generates a bunch of code, and one part of that code is this function right here, and this function will initialize the user interface for the class, and it's all just done automatically. You'll notice the convention here is that the name of that function is always the same as the name of the file, with init at the beginning and with template at the end. So there's exmsntp. That's this guy right here, exmsntp. And then inside of that template file, there's a bob list, and we'll talk about that in the user interface tutorial, but we have to tell Forge specifically that that bob list is associated with our class. So we pass in our default structure, we tell the name of the bob list. So all of the user interface things that got defined by calling this function are now associated with our class by this call right here. So that's the additional steps that get performed when a class is initialized in Forge in a graphical user interface application. So the nice thing about this is that if you are editing one of these existing models that come out of the Flames repository, all this stuff's going to be done already, and you won't have to change very much of it at all as you make changes to the class. If you use the Flames component copier to create a new class, you will always be copying one of an existing Flames class, and theoretically you'll be copying an existing Flames class that has been implemented correctly, that already works. The component copier is going to rename everything, and so you're going to start with a class where all this stuff has already been set up. So you'll never have to write this code from scratch. It'll always be already written for you. So that concludes the information that I want to tell you about class initialization. Thanks for watching this video, and thank you so much for using Flames.